Question 2, tutorial 6. In this question, we have water at 20 Celsius flow in a rectangular open channel at station 1. The channel width is 1.9 meter. Okay, so we have this channel with 1.9 meter. And the depth of water is 1.2 at station 2. We have the channel bottom has been drawn at 0.3 meter as shown, and the y is reduced to 1.6 meter here, and the water depth at this station is 0.8. Assuming ideal flow is mean we can ignore all energy losses, is a full flow in this channel. Okay. And we have to find water flow rate or volume flow rate. How to find volume flow rate? Okay, this one, if you have a look in the lectures week 6, you will know to find volume flow rate you have to find velocity and cross section area. Volume flow rate equals to velocity times cross section area. Okay, and in this case we have two stations, station 1 and 2, so you can find velocity and cross section area at 1 or 2. About the cross section area, that's easy. For cross section area 1, you have A1 will be equal to 1.2 times 1.9. For station 2, you have A2 equal to 0.8 times 1.6. Okay, so the key here is how to find velocity. And to find velocity, in this case, we have to apply the energy equation. Because inside the energy equation, we have kinetic energy. And if you have a look in kinetic energy, we have velocity. So maybe we can use energy equation to find velocity. We will apply energy equation. But for energy equation, we have to choose 2 points. Energy equation will be right between 2 points, not between 2 sections or 2 stations. Okay. Yeah, for example, if I call the point on water surface is point A, point B middle, point C for the station 1, point D water surface, point E middle, and point F bottom. So we have to choose 2 points out of 6. And if you have a look in the energy equation, we have pressure, we have velocity, and we have Z. About Z, that's easy. If we choose Z is 0 on at the bottom of station 1, you easy to find Z A B C D E F. For example, Z A would be is 1.2, Z B 0.6, and Z C 0. Okay. Velocity is what we have to find. So we have to choose 2 points, and we know pressure. In this case, point B, C, E, F, we don't know pressure. If this one is full static, we know pressure. PB equal to PA plus rho GS, PC equal to PA plus rho Z times 1.2, for example. But this one is fluid flow, not full static. In fluid flow, pressure equal to static pressure and dynamic pressure, and we don't know dynamic pressure. Okay, so PB, C, E, F we don't know. We only know pressure at A and D. And because PA equal to PD on the water surface equal to atmospheric pressure or 0 gauge pressure. Okay, so that's why in this case I choose point A and point D, because we know pressure at point A and pressure at point D. Energy equation between point A and point D shows us PA over rho Z plus VA square over 2Z plus SA equal to PD over rho Z VD square over 2Z and that's D. Okay, and as I said, pressure PA and PD is 0 gauge pressure. ZA, if we choose Z0 on the bottom of the station 1, ZA will be 1.2, and ZD will be equal to 0.3 plus 0.8 or 1.1 meter. Okay, so you see in this equation, I call this one equation 1. We have two variables is VA VD. We don't know VI and VD. So to find two variables, we need two equations. In this case, we have one. Okay, so we have to find one more equation. And at this moment, we only have energy and mass conservation equation. Okay, so for mass conservation, between station 1 and 2. Mass conservation is mean you have mass flow rate at 1 equal to mass flow rate at 2. However, this one is water. Density is constant. Okay, so for water, for liquid, we have volume flow rate at 1 equal to volume flow rate at 2. Because volume flow rate equal to mass flow rate divided by density. Okay, mass flow rate is constant, density constant, so volume flow rate is constant. Volume flow rate is 0.1 will equal to VA times area AA. Cut 2 equal to VD times area ID. Okay, with A, cross-section area, as I said, is a cross-section area. Section 1 and 2 is a rectangle. A is 1.2 times 1.9. For D will be equal to 0.6, so 0.8 times 1.6. Okay, so AA and ID you know. And in this equation is equation 2. We have two variables is VA and VD. So now, based on two equations, you can find two variables. Okay. For example, now we start with equation 2. From equation 2, we will have VD equal to VA times AA divided by AD. AA is 1.2 times 1.9 divided by 0.8 times 1.6. Or this one will be is 1.7 S13 VI. Okay. And when we have VD is 1.7 S13 VI, we apply to equation 1. In equation 1, because PA PD is 0, so we can ignore pressure energy, PA over rho Z and PD over rho Z. Okay. So in left hand side, we only have VA square over 2Z plus 1.2 equal to VD square over 2Z plus 1.1. Okay, so we will have VA square over 2Z. 1.2 minus 1.1 is 0.1 equal to VD is 1.7 S13 times VA square over 2Z. Okay, so from this one we will have VA will be equal to 0.1 times 2 times gravity is 9.81 divided by 1.7 S13 square minus 1 and square root of this one. Okay, so VA will be is 0.9497 meters per second. And when you have velocity, as I said at the beginning of this question, you can find volume flow rate equal to velocity times cross-section area. With velocity is 0.9497. Cross-section area as A is 1.2 times 1.9. Okay, so the result you have is 2.17 meter cube per second. This one is volume flow rate of water flows over the channel.